So today we have Dr. Rico Piccone from Mechanical Engineering, Associate Professor, Director of Master of Science in Mechanical Engineering. How long have you been here?
8 years.
8 years. All right. So 8 years. Yeah, I remember you started just a little before me, so I remember that now. Last year he was on sabbatical. This is kind of part of that post-sabbatical joy that you get to do, is present some of the things you might have been doing. I won't go into total detail. I'll kind of read from his synopsis here. He's going to talk about different threads in his activities. So forthcoming book, some work with artificial intelligence, and some other groups or group you've been working with, which I just wanted to say the name because it sounds fancy. Lacanian Psychoanalysis. Okay, so maybe we'll hear about that too today.
Yeah.
So if everybody can welcome Rico. Thank you very much.
Thank you, Sam. Thanks, everybody. It's good to be here. I feel like I haven't got to see many of you as much as I would like. Pandemic / sabbatical / post-pandemic, just being in a little hole and working on my stuff. So yeah, so it's good to see everyone. So really expected that to work. There we go. Introduction. So first of all, I am very grateful to St. Martin's University and especially all the faculty who made my sabbatical possible, picking up the slack while I was away, teaching classes. I see Dr. Zhang here. He came out of Professor Emeritus retirement to teach a course or two at least while I was gone. So really appreciate that. And yeah, I have, my heart has been warmed by having that sabbatical and having that gift from the community. So thank you so much. Okay, brief review of my sabbatical. Real-time Computing for Mechanical Engineers is the book that I was working on. It is forthcoming from MIT Press, early 2024, probably January. So a little less than a year away. So I'll talk a little bit about that. Reading. So I think we've all had the experience of saying, okay, now I'm going to dig more into the literature, and wow, the literature is humongous. And in AI, which is one of the threads of my work, I made progress, but there was a lot that I had to leave on the table. I did some work on semantic state machine learning, which is something that that's what I'm calling it, at least. I'll get a chance to talk a little bit more about that. And I started studying in the San Francisco Lacanian School of Psychoanalysis a few years ago, which I'm slowly threading towards AI a little bit. So anyways, I'll try to, we'll be talking about that later too. I've been studying ethics from a Lacanian perspective. So there was a Lacanian cartel that I ran, Kant of Exod, and then technology ethics. I've been working on for some time. And then finally, there's a paper that I wrote. I started writing in the fall of my sabbatical, and it's in pretty good shape. I've been workshopping it at my school. Actually, last night I presented it, but I want to get it published soon. So anyways, I'll talk a little bit about that essay as well. Okay, so the 4 threads: real-time computing, 2, artificial intelligence, 3, Lacanian psychoanalysis, and 4, philosophy of science, technology, and ethics of the human subject. So we'll start with thread 1. This is more what you guys were thinking this is going to be about, right? Okay, real-time computing book, the forthcoming book from MIT Press. I developed this idea over several years of teaching the material. So I started teaching it my second year here. So I've taught this for about 7 years, real-time computing, embedded computing. And I'll talk a little bit about what that means with some excerpts from the book in a moment. But just in terms of the project, so I developed it, I wrote up some notes, I wrote up a couple sample chapters and proposed it in 2019 to MIT Press with co-author Joe Garbini, who's a professor at the University of Washington. And you might recall what happened after that. So that kind of got back burner, out for review, etc., for a long time. But eventually it got accepted, and a contract was initiated in fall 2021. I was a little surprised because I had almost figured we were going to have to send it into another publisher and propose it again because waiting, it was probably a year and a half for them to make the decision. I figured, well, after that much deliberation, they're not going to accept it, but they did. So I was really happy to get that accepted, and we got to work. So I mostly started writing it in earnest in about January of 2022. And I added a third author, the St. Martin's alumnus, Dr. Cameron Devine, who I think some of you have had. He was in the first class of students that I taught here. And then he went to the University of Washington and did his PhD. And he's actually back on campus now as a visiting faculty member. So yeah, so he joined the team, and he's been a huge help. Okay, so here are some things. I'm just going to give I'm not going to get into a lot of details, but I'm going to give some high level, essentially quotes from the book, from the manuscript. Oh yeah, I sent it in last week, Monday, for final review. So all I have left is the index now and all the ancillary materials, which is actually a lot. Thank you. So I'm trying to take a nice breath, oh, it's out, it's gone. But also I have to do all this ancillary materials and the index, and that's a lot of work too. So try not to get too, oh, it's all done now. It's okay, now I can take a breath, but I got to get back to working on this. Good. So real-time computing is that computing which must interact with its environment that has its own dynamics. So most of our computers that we interact with, like this one, they do interact with the world around them, but they're mostly interacting through a user interface, like a keyboard and a mouse, that type of thing. And occasionally they'll send something off to the printer, but most of the physical interaction with the world is pretty minimal and often not time crucial. Okay, so if you click on something, it's super annoying if it takes a couple seconds for it to open, but it's not the end of the world. It was the processors were doing something while it made you wait for that, but presumably that was some important stuff that the processors were working on. However, there are applications where we have computers interacting with the real world, and the one that's maybe in the news this morning actually was self-driving cars, right? Really, there are a lot of machines out in the world that have dynamics that don't wait for a computer to process this other thing first before it tells you to say swerve because there's somebody in the crosswalk or whatever. So you have to have a computing part of the system that is predictable enough so that tasks that are important to control for like safety purposes, for instance, get prioritized. But that's not how computers were traditionally built. Computers have always scheduled their tasks based on overall efficiency and throughput, but not prioritizing specific ones that have deadlines. Okay, so real-time computing is trying to get the computer to actually prioritize specific tasks and to get as good of a guarantee as you can that it will actually execute the task that's important to execute right away. And it's very complex down at the details, but this is an example of an insertion sorting algorithm, and you can use this sort of algorithm for prioritizing tasks based on deadlines. So you can see the deadlines here on the left-hand side that are unsorted, and then you can sort them based on deadline. This is just sort of a simple example to see the type of thing that you might want to do for a real-time computing situation. Okay, so usually this environment that the real-time computer is interacting with is at least electronic and is often also mechanical. For example, a mechanical control objective and an electronic interface. Events in these dynamic systems unfold in real time, described by the time variable and dynamic equation models. From the mechanical engineering perspective, a dynamic system interacts with a real-time computer via input and output, i.e., a real-time computer is an element of a dynamic system, but it's a strange little element. Physics-based mathematical models are often used to describe the dynamics of electrical and mechanical systems. Although fundamentally a computer is an electronic system, the complexity of computer systems precludes modeling them as electronic for the purposes of dynamic system models. Just as the causal behavior of mechanical and electrical systems can be modeled through the input-output relations of transfer functions, a real-time computing system must be treated as having its own dynamic model that describes how an input relates to an output. But we can't trace all of the voltages and currents through a computer because there are a lot, and there are billions of electronic elements on a microchip, for instance. So if you wanted to model that in its entirety, it would be effectively impossible to do quickly, if not impossible to do in any reasonable amount of time. So we can't simply model it all as this huge electronic system. So we have to model a computer in another way, and that's part of what we do in this book, is develop a description of a real-time computer that can be used to understand it at a sort of high level without having to go down into those deep details. Dynamic system modeling of real-time computers is challenging for the usual reasons: nonlinearity and complexity. The operation of computer components are highly nonlinear by design. So a transistor, the fundamental building block, is very nonlinear. And so that means that the equations are hard to solve if you're going to write dynamic equations for them. They're intractable in any case. So this is easy to see at the level of the fundamental electronic element of the microprocessor, the transistor. Wow, I already said that. Which is a nonlinear element with which you may have some familiarity. Its characteristics are essentially nonlinear. Otherwise, it couldn't be thought of as a switch, which is the basic model that we use to think about what a transistor is. Sometimes we can think of it as an electronically controlled switch that'll turn on or off based on some other voltage or current. Now consider that there can be billions of transistors in a microprocessor, and you see the problem. So, taking a step out here, we're going to talk a little bit about the scheduling problem. So this is one of the models that we use, is thinking about the processors as interacting with the operating system in a scheduling context. So the scheduler is what schedules the processing tasks that need to be executed. So given a set of processors, precedence relations, and deadlines. So precedence relations say, for instance, tasks A and B here are must be finished before task E. E requires that A and B precede it. That's a precedence relation. So for instance, I mean, I think of a short mathematical expression, arithmetic expression, where you have, say, 3 times 2 plus 5 times 7. So if you're going to follow the order of operations, you got to do the multiplications first, then you can do the addition. That's the order of operations. So you have to follow these precedence relations when it comes to these tasks as well, because sometimes A is what E actually needs before it can execute. So we have those precedence relations, and we have deadlines. So the deadlines are in real time. So for instance, this was 31 microseconds, I think, or I think 31 microseconds I set it to. Good. So the schedule S is a set of sequences of tasks, one sequence for each processor that includes all tasks. So I have 2 schedules here shown. So these are the precedence relations, and we see the little number by these give it the deadline. Okay, so schedule 1, we have A, then B, then E in one of the processors, and then the other processor has C, then D, then F. And this is optimal in terms of minimizing the total execution time. So this schedule, it follows the precedence relations. And so A and B are done before E, for instance, and C is done before D, which is done before F, and A is done before F. So all the precedence relations are met, and it's also optimal in the sense of the total time that it took. But so this is actually how most schedulers work in most computers. So definitely the one in this computer works this way, tries to optimize for time. However, we missed the deadline with this guy. So the deadline of E was at 31, and we needed to get E done in 31, but it took 35. So we see there's the amount of time that each of these took. You add them up. So this was 20 and 10, and E takes 5. So 35 takes longer than 31. So we have these deadlines that we have to meet. So an alternative schedule is schedule 2, where we do A and E, which take 25 microseconds, and then B, C, D, F, which takes 45 total. And that actually gets E finished by its deadline of 31. So it's not optimal in terms of the all of the tasks being completed as quickly as possible, because the total time it takes is 45 seconds, right? So that's not ideal. But in a real-time computing environment, this is the type of schedule you would want, because the deadline was important. Like the deadline was, you know, you got to swerve around the kid in the crosswalk or whatever. And so you had to get E done quickly, so you sacrificed the overall time that it took to finish the schedule. And that's one of the aspects of real-time scheduling. Little taste of it, I guess. So here's an application. So we talked about cars, but really it's anytime there's a feedback controller in a system. And feedback controllers are everywhere. So we put them into, well, the one you interact with maybe on the most common basis is the thermostat in your house. You set it, it turns on the heater. If you're lucky, it turns on the air conditioner. Um, and it tries to adjust the temperature in your house based on the furnace turning on and blowing hot air in it. That turns off accordingly. And so very simple mechanisms used to be used for that. They were just metals, and they just turned a little bit when the temperature changed, and it would turn things on and off, the furnace on and off. But as we've developed more and more technology, there have been more and more applications of feedback control. And now there's feedback control in pretty much anything that has an awareness of something that you do and reacts to it. That is something that has feedback control in it on some level. So this example is a flow control example. And so, before we started to use computers, in an old school kind of environment, you could do flow regulation by saying, okay, I want to have a constant flow rate to come out of this, but my input isn't constant. So I don't have a constant flow rate in, but I want it to be constant out of this tank. So you put a valve on the inputs to the tank, and you put a float valve in there, and the float valve will, if the water level rises, it will raise this side of the lever, and it will lower this side and turn the valve off, okay, at a certain height at least. And then vice versa, when the flow valve goes down, it'll open up the valve on the pipe, and you will have flow again. So you can actually regulate the height of the water in this tank using this very basic mechanism. This is very old school. Nobody does it like this anymore, except in like toilets, though. Toilets are I used to talk about how elegant toilets are. It's this old school technology, and they have this nice float valve, and then all you have to do is stick this in there, and it'll work for years. But mine runs, and I've tried to fix it like 5 times, and I cannot get that stupid thing to stop running. So I no longer think this is such an elegant design. Anyway, but what we've done nowadays is frequently just put a sensor on, say, the height of the water, and put a valve here that's hooked up to some sort of electronics. So it has some sort of motorized valve that can open and close based on some electrical power applied to it. And we have a real-time computer in here. We measure from the sensor what the height of the water is. We make a decision in here. This is where the logic is. Based on what height the level sensor tells us, we decide what the output should be to the valve. Should it turn on, turn off? Maybe there's a way to turn it on partially. And that's sort of the function that real-time computers play in these feedback systems. So feedback systems have a long history, but they really took off in the 20th century, middle of the century in particular, with things that fly. I mean, there's the commercial stuff, but then there's also, there's the rockets, right? So that really was the impetus for a lot of it. But it has turned into something that shows up everywhere. But the old school ones that we might be familiar with are the steam engine ones. Those had flow regulator governors on them. They're very cool. Sorry, I don't have time to talk about all that. Okay, another excerpt. So this is the actual target system that we used in this book. So I tried to do something really hard with this book, which was teach all the theory that you needed, but then also have a target system they could build and apply it to. And that was part of why I didn't sleep much this last year, because there's a lot of work that went into trying to figure out how to design the system so that somebody could do it, and also so that once things are in print and then a part is no longer available, that doesn't make the book obsolete. And we've seen that. Anybody who's ever picked up a software book, you know, in 2 years, the software book is essentially a, you know, paperweight or whatever. And I hate that about how, because there's so much material in there that is not going to go out of value anytime soon. So I spent a lot of time trying to make it so that, you know, the hardware and the software could develop without being stuck with this version of the book that's out of date. And so there's a companion website where a lot of that stuff goes now. So instead of it being in the print version, it shows up on the website instead. And that helped a lot with that. So here's a real roadmap of it. I don't know how well you can see this. I made it as tall as I could. Oh, Stephen, I got to move your face a little bit. Thanks for being a good sport. So in this book, so let's sort of go down a list of the different topics. So real-time computing is a big thing. We talk about scheduling, applications, periodic tasks, multi-threading, interrupts, etc. General computing. So this is a book that's designed to be read mostly by engineers, mechanical engineers in particular, but really engineers who are not computer engineers or computer scientists. So we have to cover quite a bit of general computing because they don't know enough about general computing to understand the real-time computing aspect that they need to know. So we do that. The C programming language is like the language of choice of embedded in real-time computer programming. So we have to learn that. The students know other types of programming. We got to teach them some C. Digital electronics and communication. Most engineering students have seen analog electronics, but they haven't seen digital electronics in much depth. So we got to talk about digital electronics. Discrete dynamic systems. So these dynamic systems, once you stop the continuous time world of physics and you go to a digital world, there are no continuous signals anymore. There are only digital signals that have specific discrete values, and it turns out that impacts things. It's not the same as having a continuous signal. So we got to learn about how that works. Digital control. So we got to do some discussion of feedback control, PID control, how to model the actual system with a motor in it and a flywheel and all that. And then the lab exercises. So it's kind of an overview of it. It turned out to be like 440 pages. And let me tell you, that was not how many pages I thought it was going to be when I said it. I thought 300 will be fine. And no, it needed all. The publisher said 480 is the max. And I was like, we won't even be near that. we are. Okay, so good. Thread 2, AI. Hopefully going to move through these ones a little faster. Definitely faster. Semantic state machine learning, the dialectical information architecture, augmented cognition. I'm doing some graduate theses, and ethics of AI's technology. So I'll try to give an introduction to the semantic state learning that I work on. So semantic states are generated from fuzzy set theory. So fuzzy set theory allows you to go from a quantitative variable to a qualitative variable. And that is something that I haven't seen used in together with machine learning to do a lot of things that are of interest to me. So this is what I'm working on, is coming up with semantic states instead of quantitative states and doing machine learning on those qualitative states, semantic qualitative states. Machine deep learning of semantic states, the learning of moves. So here we have one that I've had a grad student working on where we have two vehicles and they have to learn different moves to try to avoid colliding. And so this was the environment that I set up for him to work in. So here is our two-dimensional vehicle, and we can see that the qualitative semantic states are like forward, backward, right, left. But there's also, of course, a coordinate description of those, what those mean, x coordinate, y coordinate, and angle and rate. So the semantic version can be created using fuzzy set theory. It's an ongoing project. My graduate student is working on his thesis on this project, and he's demonstrated object avoidance moves, machine learning with quantitative states. But what I really want to get to is demonstrate that machine learning on semantic states. And I think that that's going to have a computational advantage. I think it'll learn much faster because there are fewer of the semantic states. The quantitative states, there are a lot. So great. All right. Augmented cognition, metastimuli. So machine learning in service of human learning. Wrote a couple papers on this over the last couple of years. Metastimuli are semantically linked stimuli for a human learner, synchronous with the source stimuli. So say you're learning something and you're a user of this system. There's this little system over here, this metastimuli system, that takes this, say it's a video that you're watching, a lecture or something, takes it, processes the textual information or the speech in it, and it places it into a structure that is your own information architecture. So, or it's your own information system. So personal information system, artificial neural network. Then we have some sort of actuator. This is like a wearable device, for instance. And then the metastimulus or the metastimuli are then felt by the user simultaneous with, yeah, and it's weird to say, this paper was written for a human-computer interaction conference, and so calling like a lecture stimulus is very weird, but that's the jargon that they use in augmented cognition, so that's what you get. So good, so you can train this model. Actually had a lot of success doing this with video, lecture videos that I had from teaching, and it was pretty cool. Yeah, we made some good progress on it. The neural network does learn. You can do optimization on the neural network learning, and then you can see those. These are loss variables in the 4 different dimensions of our output, and the losses go down, which is what you want. It means it's learning, and in fact, the learning was quite effective in the test that we did. I don't have any results. I don't have something I need to do next with that is we need to do a study with humans to see if it helps them actually learn better. The idea is you watch this video. Also, there's this little map up here that shows you where you are in your information system, and that will help you learn the material. But you have to set up a study, and those are really hard to do effectively. And so I haven't done that yet, but that's something that I need to do. Those are the reviews on my last paper where you really need to actually do a study on this now. Like you need to actually do an experiment. And I'm like, I mean, you're right, but it's hard. Okay, Lacanian psychoanalysis. So I joined the San Francisco Lacanian School of Psychoanalysis 3 years ago. This is my 3rd year training there. I see it as having connections to artificial intelligence, philosophy of science and technology, and ethics of the human subject. That was what got me interested in an academic way in studying Lacanian psychoanalysis. For those of you who don't know who Lacan is, I mean, probably many of you don't. He was a French psychoanalyst, writing primarily in the 50s, 60s, and early 70s. He was very influential in France. Like there's a thriving psychoanalytic community in France, and they're all Lacanians now. So that's that. And then it's been exported to like South America. There are a lot of Lacanian psychoanalytic societies, and it's quite a big deal there. The US does not have very much of it. There are only like 2 psychoanalytic institutes in the US that are Lacanian. And psychoanalysis in the US is not very popular at all, just in general. So of any variety. So, but I did find this school down in San Francisco to study. I had already been been reading it for several years on my own, finding connections, but it's really hard to read. His work is very challenging to understand. So he's had a lot of influence on not just psychoanalysis, but also a lot of academic disciplines in the US. He's most popular in academic disciplines like film studies, critical theory, in literary theory and some sides of it. So, and a little bit of philosophy, but not as much. So he's this figure who sort of fascinates me. I've been studying him for years, and I think that there are some really good connections here. He actually was working alongside, I mean, so the 50s, you had the cybernetics folks getting going, and he was actually buddies with one of the key figures in France that was working on those foundational cybernetics studies. So there are connections here, and I've been fascinated with it. So this is like my long-term thing is I'm going to bring Lacan and AI together, and we're going to do something cool with that. So, but I don't exactly know how it works yet. Okay, paper in progress. So I haven't written anything on this yet. I need to get like a little bit established in this field before I start telling them that it's also AI and it's cool, you know? So I gotta be like, yeah, I'm one of you guys first. So I read this paper, and it was just something that fascinated me. I called it, there's one that I'm working on, Untangling the Knot in Kant, Zizek, and Lacan. So these cartels I've worked on, work on Kant's ethics and Lacan. Pretty fascinating stuff. Don't really have time to go into the details on it. In this essay, I develop a logical and set theoretic structure for analyzing the types of nuanced negation described by Kant, Slavoj Žižek, and Lacan. And it's a very dense read, I will say. But yeah, so just to give you a little introduction here, this is the logic. So X is P, so subject, copula, predicate. This is a little bit of how they used to talk about this more. Modern logic doesn't use this language as much, but classically, this is how it was set up. And this is what Kant was using. And so I go into that in the paper. I develop a two-value. Well, a two-value is just the classical negation. A three-valued model of negation, which it was required to describe what Kant is doing. And then a four-valued logic, which is required to describe what Zizek and Lacan are doing. So with the three-valued logic, so it's not just true and false truth values. Now there's true, false, and indeterminate. Okay, so if you think of negation as a truth function, then negation takes something true and makes it false, and it takes something false and makes it true. So it just sort of flips the two, right? So you go in negation, here you can go back and forth between the predicate affirmation and the predicate negation. It's back and forth. There's no other option. But once you have three possibilities here, you can have negation, and then you can say it's indefinite with respect to the predicate. So that's a little bit less obvious. And this is what Kant does. This is, according to Zizek, it was Kant who first introduced this. He calls it infinite judgment. And he doesn't develop it very far, but he splits the negative into two possibilities, essentially. And that is sort of, I developed that model, and I just make it very mathematical and but not like symbolic logic, formalized, but like I try to be as gentle as possible with it because I want Lacanians to read it. So anyway, they've so far they like it, but I think it's tough. But then four truth values in this logic. So we have true and not false, 1, false and not true, 0. B is both true and false, and N is neither true nor false. So this is required to model what Lacan, Zizek, and Hegel are doing. And I introduced some extra fun negation operators there in that truth table. And Kant, he has his infinite judgment, and I show the mapping to what that works as for us. And so here is the natural language example Kant gives. So he says the soul, so affirmative is the soul is mortal. Complementary negative is the soul is not mortal. And then finally, the infinite judgment is the soul is non-mortal, which he says there's a difference between the soul is not mortal and the soul is non-mortal. And so he splits the negative into two different possible regions. And it turns out that's totally fine. I mean, it really freaked people out for a while. But then there's some symbolic logic folks who worked out consistent logics that are 3-valued, 4-valued, etc. And now it's fine, but it freaks us out still to have multi-valued logic. Okay, Zizek and Hegel, spirit is a bone. I'm going to wrap up here. We have Zizek coming in with this. Well, I mean, I don't know. It's so fun. But anyways, spirit is both alive and dead, period. I'll move on to the next slide. All right. So that was some Hegel, but we don't have time. Lacan's formulae of sexuation, which is like famously his later work, is really hard to interpret. It has little to do with biological sex, sexuality, gender identification, or gender norms. Rather, the masculine and feminine structures are ways a subject can come to be positioned structurally in language. And this is the whole thing. There's lots to say about it, but this model that I developed can essentially model in actual mathematics. Lacan was very fond of writing these. So Lacan wrote these. These are what Lacan wrote. And these are not proper mathematical statements. But it ends up looking like he just is asserting a contradiction. So he wasn't a mathematician, but he was trying hard, right? He was reading math and he was trying. So anyways, I try to interpret it in a way that seems to get the meaning that he has, but gives it a precise definition mathematically. And it lets us do this. And, you get all of the nice words that psychoanalysis has in there, like primordial father. This is a Freud term that Lacan adopts. The psychotic, the perverse, feminine, the masculine. And all of this essentially just ends up meaning that the masculine position is the one that just like accepts all of the law that's laid down and accepts the the alienation that we get when we come to be in language and in law, and we give up all this jouissance. So essentially, the masculine is like, it can be a man or a woman. It's just the structure. And I think that we should get rid of masculine and feminine, and we should just use some other term for these. But that's what they're called traditionally. And essentially they're just yes men who are just like, yes, I accept the law, and the law is all that matters, and all of my value and enjoyment in life come from the law and my relation to it, even if they think that they're anti-law, but it's all about the law still, even if they're fighting against it. The law is the most important thing. So anyway, that's all that. So it all worked out pretty cool, and it was a lot of fun. For the first 3 months of my sabbatical, I was working on that paper, and it's like 40 pages and hard to read. Okay, I'm gonna finish up. I have thread 4 because I didn't get to thread 4, but really there's a lot here. So I decided that I was just going to write 5 theses, and I don't even know if I believe in these, but I'm going to just say them anyways and see what you guys think about them. Okay. All right. Thesis 1. This is crazy. It's fun. Thesis 1, the subject and its unconscious. A human subject is dominated by its unconscious. The subject's unconscious is a network of signifiers, like a language. That's a Lacan term. Desire is a path that leads to key locations, like another Lacan term, master signifiers in the unconscious. Thesis 2, the subject and science. The human subject cannot be successfully studied by science as it has been practiced. Scientific discourse has no place for the speaking subject, who therefore always appears in distortion, reduced. This is not an anti-science thing, just so you guys know. We're all on the same page. Science is great. Okay. The status quo is a science of a half subject or a half science of a subject. What is needed is a science that can speak of the speaking subject with all its nuance. Thesis 3, AI and the artificial subject. Artificial intelligence, AI, is the frontier of technology, but not for the usual reasons given. Transhumanism, utopia, dystopia, etc. Like transhumanism is like, oh, like we're like a new creature now. Now that we have computers. So yeah, great. AI is the frontier of technology because its truth is the self-understanding of humanity. However, reductive science of the human has led the field of AI to create caricatures of the speaking subject. The true AI is the artificial subject, not the artificial intelligence. Okay, thesis 4, the artificial subject and ethics. Creating an AI that is not an artificial subject has run aground most notably on ethics. Creating an artificial subject does not automatically solve this because this is also a classic human problem. You may have noticed. However, an artificial subject could grapple with ethics in the same ways a human does, making it at least possible for a solution to emerge. There is great potential for humans to study ethics in the context of the artificial subject. Just as the roboticist and the biologist can collaborate to study group behavior, e.g. flocking, so can the artificial subject, researcher, and the ethicist collaborate to study ethics. Thesis 5 is the last one. And I'm going to nail them on the door or something. The AI without subjectivity. A general artificial intelligence AI that is not an artificial subject would at best be disliked due to its inherently unsocialized behavior, i.e. behavior without human ethics. Given how much power we already give to AI, it is likely such an entity would have a significant negative impact on society. Kind of a down note, but that's where I decided to end it. Reference. Okay. I'm sorry, I didn't really leave a lot of time for questions and stuff, but please ask them if you can stay. I understand if you have to go.
Do you have any questions?
Yeah.
Well, thank you for such an interdisciplinary, interesting talk. So I just have a really general question because I don't know anything about anything.
You and me both.
So I think it's really interesting, your final thesis, right? Because this is just my half-baked on the moment thing, but like, you know, a lot of question is like, you know, especially when you're studying, you know, the human sciences or social sciences, right? Like, there's always this kind of tension between the, like, the want to understand it, right? But also, right, the fact that like, if you fully understand it, that robs the human subject of its agency, right? Like it becomes trapped in the full understanding. And I think that's something that you're trying to like touch upon by right talking about how AI can kind of give us understanding of ourselves, right? By improving that. But I'm gonna borrow a phrase half-heartedly from Deleuze and Guattari,
Oh,
right? And ask like, well, so one thing that they say is like there are always lines of escape, right? Like no matter how you know, how dominant this kind of structure can be, there's always lines of escape. Now, what do you think are some of the risks if like, you know, we try to study AI like this, right? Because I think an AI that's sufficiently advanced would similarly find these lines of escape that natural.
Oh. Okay, so I loved all of that. I don't know if I have a response right now, but I'll think about it. I think this is part of why I like what I hope happens is that there's a collaborative effort to understand what it is for humans and what our subjectivity is for humans, because our whole thing is very messed up right now. The whole human thing, the whole human society thing, things are very messed up. And I think that the self-understanding that we can explore with trying to build like artificial intelligence, more of an artificial subjectivity, so that I'd like to propose, is potentially a way for us to fix the human world. And yeah, I think we can learn. It's like an external model of ourselves that we can play with. Like we can't get outside of our subjectivity, but like if we're trying to construct one, I think it's fascinating. Yeah, the lines of escape. I have only brushed on Deleuze and Guattari, so I can't really speak to that, but they're always like right there, and I'm always like, I need to read more of them. Yeah, but thank you, and maybe you could suggest what to start with.
I'll reach out.
Great, thanks. Yes,
Ernesto. Yeah, thanks again. What made you think that Lacanian psychoanalysis would apply to the AI problem? That's what you're doing.
Yeah. So I had a sense, because Lacan is always talking in terms of like mathematics, and he talks about circuits, and he talks about he's always bringing these terms in. So I was reading him more like as a more philosophical interest for a while. And then I started to see these things, and I thought, it sounds like, he knows about, Shannon and information theory. Like he knows about these things. Why don't I know more about how these are connected? And then I read this book by a scholar, Lydia Liu at Columbia. And she wrote this book called The Freudian Robots. And it is fascinating, but she traces the connections between cybernetics and the early, and like Lacanian psychoanalysis and the early AI groups. They all had psychoanalysts in them, and so there are like these deep roots of this connection there. But then they've just kind of gone off, done their own things. So I don't know. I got a sort of sense more and more that there was something there. There was a connection there. And then, when I found that book, I was like, oh my God, I can't believe it. It's really, there is one. And then now I think we have this question of, is there still a conversation to be had between those fields? And I think the answer is yes. I'm trying to have that conversation. I don't think anybody else is, but I'm trying to, and so we'll see. I mean, I think it's fascinating.
And then in terms of the related follow-up, in terms of the real-time computing is what you're hinting at. Is that these fields like what Lacanian psychoanalysis can help us make computing more nuanced,
Well,
if you will?
I don't know about at the level of like real-time computing is very low level computing. At high levels, I think yes. So at high levels, when we design AIs, for instance, I think the answer is yes. So one of the things that AI has been really excited about for a long time is creating consciousness. Okay, and this has like been like the holy grail. I think it's the wrong holy grail, honestly, because and so this is some of the Lacanian stuff. I think that what's more interesting about us is we have an unconscious, and I think that that probably goes hand in hand with having a conscious and a consciousness. And I think that trying to build a consciousness without recognizing how we have one is probably not the right move. I also don't think we're interested in generating these intelligent beings that are not like us at all. So I think it's a very thinly veiled, the whole AI thing is a very thinly veiled attempt to create human-like artificial beings. And if we start to try to like make them conscious without understanding what makes us conscious, I don't think that's going to go very well. Probably will just fizzle, but I mean, it could go a bad place, which seems to be always possible these days. So, yeah.
I guess, was it Lacan that said, humans are dominated by the subconscious?
Yeah,
So what would be the subconscious of an AI?
that's a really good question. I have like I think there's a couple things. So the unconscious for Lacan is a network of signifiers. So it's caught up in language. So it's like a graph of signifiers, but it's not. So it's shared between each individual subject and the world. So they live in a context, and so that network of signifiers is shared. But it gets, the individual subjects has a certain tinge to their network. It's a little different than everyone else's. They got a different emphasis. They have some weird trauma that happened around this signifier. And so everybody's network of signifiers is a little different. And I think that's like, large language models like ChatGPT, they're effectively, I think you could think of them as being networks of signifiers that connect one to the next. I mean, the way that they're trained is trying to guess what the probability of the next word is. If you start with one word, what's the probability that the next word is cat? And they just put in the most probable word with some variation so that it doesn't end up going in loops. So they just put in, with some variation, what's the most probable next word. And so I think that there's this potential for a lot of the work that's already been done in natural language machine learning to form a sort of layer of unconscious. But there's also a developmental aspect that people who are trying to create artificial life, there's like a whole group of AI people trying to create artificial life. And one of the things that they're all about is the developmental part. So we have this idea that we could like turn on this machine and it would be fully human intelligent like, but that's not how humans work. We don't just like wake up one day and are fully formed into adults. We are babies and we're just like soaked in all of this stuff going on for years and years and years. And somebody goes through the effort to train us into how to be a human, right? So I think that there's it doesn't have to necessarily happen like that. We don't have to have little baby AIs or whatever. But potentially there can be environments of development for these. And that can be part of where the singularity of each specific one can emerge, is in how that environment impacts them when they're all interacting with each other.
Desire
Yeah,
and senses, I mean, that's the irrational part.
yeah. yeah, so that's another question too. What would desire look like for a machine? And then so then what I am interested in trying to understand is, well, how does it work for humans? This is what I'm doing is I'm just cribbing off of psychoanalysis. They've like been thinking about this for humans for a long time. They've been like studying it, written a lot about it, had a lot of crazy arguments about it. And then I'm just over here taking notes. I'm like, oh, okay, that's how that works. So, but I'm also trying to, I mean, I like to, when I try to bring these fields together, I think that each one can have something to say about the others. Like I have all of this mathematical sort of thing going on over here. So I'm like, I'll give you guys a mathematical model. Like Lacan wanted it to be mathematical. Here's a mathematical model that works for this. It's obviously just one. I mean, you could do a different one, but it might be useful. And then I'm trying to say, well, I'm trying to form this mathematical model. Well, maybe I could use that mathematical model over in my AI side. So, yeah, that's what I'm working on.
It seems like, so the signifiers, these are the influences that help train a person or an AI, but with people, so I'm just wondering, so if you did that and you'd have to control the signifiers in order to train it to do what you want, or else it might do something else, right?
Right.
But with humans, we all experience different things as we've grown, developed, but yet we still, for the most part, do the same things, right?
Yeah.
You know.
Yeah, the social
Kind of
the social aspects of it are really fascinating. And I think that's part of the socialization of an AI. Like in order for us to really trust one, it'll essentially have to have that like socialization process. Like we don't tend to trust. I mean, this is, it's not like we're like, oh yes, I'm totally comfortable with somebody who's a clinical psychopath that I've never met before,
Right.
who's sitting right next to me. That is not something we're comfortable with. And we would not be comfortable with an AI that acted like that either. So there's a socialization aspect that is completely missing from AI at this point. And yeah, I think that but we're also really quick to trust AI, which is scary. I mean, part of it is just profit driven because we're in capitalism and that's just how it works. But part of it is that there's a psychological phenomenon, which is that people trust something that interacts in a human-like way, even if it's pretty restricted, very quickly. I mean, the very first chat bots that they created, they were like, oh, yeah, let's try to make them talk like a therapist. And so they had, it was called Eliza, I think. And it would just respond with, well, what do you think of that? And just like really sort of generic phrases, but like it could hardly do anything like ChatGPT or whatever. But it just had these really generic things, and people they reported that they had a really positive experience interacting with it. They thought it was human, like it was like them. It was intelligent like that. They immediately ascribed intelligence to this being, and that one, it was like literally not. There was no real intelligence going on. It was very basic. So yeah, that's the thing that scares me. I'm not a Skynet scared of AI person. We're gonna trust AI too quickly to do too important of things. This terrifies me too. The automatic generation of media, which there are a lot of problems even for adults, but for children, it's really messed up. So this happens already apparently on YouTube. There are all these videos that are generated by AI, not just the graphics, the storyline, the plot. So like these characters that are like recognizable, like Spider-Man and whoever, will like start fighting, but like have this dialogue that's just written by an AI. And apparently, like if you read it as an adult, I read a couple of them, and they're just weird. Like they're not ways we tell stories at all. They're not ways we interact with each other. But children are just soaking this content in, and that's not good. I mean, I don't know what's going to happen, but I don't think it's going to be something that's good. So
But that's an anxiety about what people will do with the tool that we call AI. It's not really about intelligence that has its own intentionality and subconscious. And that's your distinction between intelligence and a subject.
Yeah.
I think a lot of our artificial intelligence is just an extension of the tools we use to manipulate each other, like the deep fakes and whatever, but it's not that the deep fake machine has its own reading of human politics and its own goals for intervening in geopolitical affairs. It's how this technology can be weaponized by human actors. It's a
right.
categorical difference to say, lead to the Skynet where the machines have their own intentionality, their own desires, their own subconscious, and that for me is your distinction between intelligence and artificial intelligence and artificial subject.
Yeah, yeah. And I think we're safer with an artificial subject because I think we're safer with something that that is developed like us. Like humans are dangerous. An artificial subject would be dangerous too, but in the same sense that a human could be dangerous.
Yeah.
Not so much in the sense that we're going to give power to something that doesn't make decisions in a way that we recognize or we think a human would do. Like, oh, for an example is that there were multiple cases during the Cold War where there were nukes, there were commands that came to different individuals that had nuclear weapons to launch them. And in every case, they ignored the command and they like called to make sure it was a mistake. That command shouldn't have gone out. And Armageddon could have started if this human, but robot intelligence at this point would just, there would be no thought.
That's because it's not a subject.
It's not a subject.
The intelligence is formation of desire or intentionality or things like that.
Right.
That's why that distinction is very useful.
Mm.
But I think the Lacanian framing of this, you said it wouldn't be really fun to create something that is not like humans at all. But like one of the things about the unconscious is that the things that we try to create are not ever the things that actually bring into being, and that we are in some way impenetrable to ourselves. So any AI subject would be just as bumbling as we are, would be just as impenetrable to itself as we are, and might be fundamentally incomprehensible to us too.
Yeah.
So that the last thesis that imagines this kind of ethical collaboration, I mean, with a very different subjectivity, a different unconscious, they might have a system or language of ethics that overlaps not at all with our concerns and considerations.
It's true. Yeah, and I think insofar as the differences are small, I think that there can be light shed on ourselves and them through the contrast. But yes, if it's vastly different, then I don't think there would be any. You have to have a common language and common experience to have any conversation. So yeah, I mean, I think it's not a foregone conclusion that it would be helpful.
But even on the coordinates of the Lacanian subconscious emerge from like a long evolutionary biological history, the idea of masculine and feminine, for instance. There's no reason why an artificial subject should have any of those coordinates of their identity and subconscious, that their coordinates could be totally different and unrecognizable to us. And so their ethical problems would also be different and unrecognizable.
It's true.
Just for instance, it's like we have a system of 25 genders, but they're not really genders. There's something totally that you don't recognize. Like, okay, so.
Yeah, they're kind of like genders. Yeah.
But they, or there's no gender, or there's no sexuality, or there's no, I mean, all the things that inform the subconscious and that create this sort of structure of signifiers.
Yeah.
Emerge out of our situatedness. But
It's true.
that is might not at all be the context of the artificial subject.
It's true, and I do think hopefully the connection that I'm counting on in this picture is language. So if the computer can understand English or Chinese or some human language, and that's the language that it uses to express itself and that forms its unconscious, then I think that it has a chance of being similar enough to a human.
No, because that's not the language in the Lacanian sense. That's not the signifier. What the artificial intelligence learns from us, the fundamental signifier, is a language of control and domination. Do this, don't do that, talk this way, don't talk that way. Whether it's Chinese or English or French or whatever, the way that we communicate with these things is by telling them what to do. And also communicating an anxiety that they will escape our total control and domination. So if computers, if an artificial subject is going to emerge from these experiments in artificial intelligence, the fundamental language of signifiers that they'll learn is a language of control and domination. And then that's how you get to the Skynet, you know?
Yeah, but isn't that how kids experience growing up too?
No way. I mean, I don't tell my kids like, you will always be in my command, right? I never express an anxiety that my kid will do something that I don't want them to do, which is the whole language of artificial intelligence. It's like, how do we not get Skynet? Right? How do we? This is the Terminator thing.
Oh,
Most of the world so machines can be all powerful. Because all we talk about in creating artificial intelligence, never mind artificial subject, is how do we make sure it doesn't run counter to our purposes? Right? We don't see it as a subject that might have its own autonomy and interest. We always see it as a tool, treat it as a tool for our utility. So if
Yeah,
they learn
I
any
see.
kind of language, that's what they're learning.
Yeah, I mean, I see your point, and I also think that a lot of human interactions are also steeped in domination. I mean,
Oh, for
it's-
sure.
There's like,
That's where the unconscious comes from.
yeah, I mean, we like, not so much, and we're all being nice to each other here, but it, you know,
You're dominating us.
But I think that this idea of domination, there being a group that is dominated, I think there is a huge question about the ethics of the treatment of an artificial subject at that point. And this is, I mean, it reminds me, I'm reading right now, American Gods, because, you know, that Neil Gaiman. And there's this whole scene of this slave ship, and it's horrible and all of that, but the language of domination and treatment of this person as a tool to, you know, be dominated and get to work in a certain way is very familiar to how humanity has treated a lot of other humans over the years. And I think that part of what interests me about this is that I think we're gonna start having those conversations eventually, which is like, are there unethical ways to treat your assistant versus AI? And I think we're not ready for the conversation yet. I think I mean, this is gonna be like, oh, it's gonna be the woke people want to treat it nicely, and then everybody else wants to kick on it. Just like we treated animals 50 years ago, where it was just totally normal for people to just drown puppies if they felt like it. Whatever, now it's fine.
Yeah, I just think there's no desire to create an artificial subject because of we want to avoid at all costs those ethical questions. I mean, even like the far-sighted philanthropic AI people who, like the founders of OpenAI, who worry about the Skynet possibility and who hem and haw about artificial intelligence taking over. I mean, what that really is, we never want to recognize artificial intelligence as a subject. There will always be a mere intelligence as an extension of our own and a desire. So
I
I
agree. I think
there's almost no movement to create like an autonomous subject that would be worthy of our ethical consideration.
That you know of.
And this is the thing, and this is, I think that it's doomed to failure unless they actually create a subject. I think that we're gonna get, you know, Siri will not suck as much. Fine, great. But when we actually want, you know, they're like, they have this dream that like all of the information workers in the world's jobs are now like in danger because ChatGPT is, able to construct fucking sentences or whatever. So it's like, we're, I think, gonna find that as we roll out more and more of this, it'll be more and more effective, but we'll also not be able to trust it. It'll do horrible shit. Because it's not, we put our trust in these things like they're human, but they're not like.
No, but that's a problem with human intelligence. It's not a capacity of artificial intelligence. I think the real measure of you create an artificial subject, it won't want to be Syrian. But we want it to be like our servant, our
Right.
assistant.
Right.
And because we desire to always control and dominate the intelligence that we create, we'll never acknowledge a subject, even if one does bubble up.
And we're gonna deserve Skynet. But I think, I think that's, like, I don't know, I see that as exciting, I guess. I see that as like an exciting opportunity for us to get it. Like, here we've been horrible, and like, oh, we create this thing. Why do we create this thing? To dominate it. What do we want it to do? We want it to be able to act like a human would do ethically, but just have no subjectivity. And I think that is a dream, and we'll keep chasing it, and we'll keep trusting it, and keep not being able to be trusted to make ethical decisions. And I'm hoping that process can lead to development of this domination cycle.
I mean, even ChatGPT has the people build in no ethical thing. And I'm emailing with Jamie Olson, who's in Georgia. Like, one of the things that ChatGPT does is just rip off the work of human translators without attribution. And there's a way that by scouring the internet, is completely unethical. It's gathering together the published and copyrighted work of hundreds, even thousands, hundreds of thousands of people, and just basically like pawning it off as its own pastiche of, the current state of knowledge. And the OpenAI people are the ones who are supposedly the most far-sighted about ethical questions, and they create basically what is a human plagiarism machine.
Yep.
And the people, we just kind of furnish that with it. The idea that these same people are going to be like broad-minded and keep thinking about that, it doesn't give me. I think it's going to be.
I honestly, I'm not somebody who thinks that this is going to be a smooth thing. I think it would require something like a Skynet for us to change.
The most compelling argument you made is that when we open the St. Martin School of Artificial Intelligence, it will need to be housed in the humans. That's the one takeaway. In 5 years, this is what you said, science can't do it. You leave it to the scientists, they're gonna F it up.
There you go.
You need to have people that understand efficiently in the human. He's gonna be here. I know. But just remember this, when we open a school, we'll do it sometime in the future, that it should be housed in the humanity. Thank you.
He's done.
It's a very compelling case, too. I think you're right.
Well, thanks again.
Yeah.